Hello everyone, this is lecture 174. We will try to discuss the Porter frames with inclined columns. Suppose if it is a frame in which maybe one column or both column may be inclined. So what will be happened due to sway, how much moment will be created? That is part of our study. So let us think that this is deflected by this value is your lambda 1. This is your lambda 1 which is deflected with 2 inclined, and this is your lambda 2 which is deflected in this direction, that is delta 2. This is angle theta 2 which is making with the vertical. The inclined portion, the inclined column is making theta 2, this one, and this one is making with vertical, that is inclined is making with vertical, that is your theta 1. This is A, this is your B, this is your C point, and this is your D point. So what will happen due to sway, there is a desire of deflection, there will be a shifting B to B1, that is B to B1, and C to C1, but these two will be equal because shifting is equal symmetrically. So this B1 equal to C1, that is horizontal जो deflection है वो दोनों में बराबर होगा. Let us try to understand this delta 1 and delta 2. This is delta 1 and this is your delta 2. So this will incline and will be perpendicular, and this is inclined and will be perpendicular. This is like this is in this way, so this is just like a making angle theta 1 with respect to horizontal. Instead of this is making with theta 1 with inclined portion with vertical, and this is making theta 1 with respect to this. You can find out in this way. This is your like this is like this. So what is this? This angle is 90 minus. So this angle will be how much? You can find out if you put somewhere here this 90. So you can always find out this angle theta 1. So the vertical angle, this one is theta 1, right? So this angle will be 90 minus theta 1. And this is already 90, so this will be your theta 1. This will be your, how? This is your theta 1, so the vertical component will be theta 1, but it is 90, so 90 minus theta, so this will be, again this is a 90, where this is a perpendicular to this line, so this is your 90 minus theta, and this whole angle is 90, so 90 minus theta, this will be theta 1, this will be theta 1. Similarly, in the other direction, this angle will be also, this is extended, this angle is also theta 2. This is theta 2. So what is total deflection, you can say, is your this part, this and this vertical. That is B1, B2 plus C1, C2. So B1, B2 is vertical component. Vertical component means that is B2. If you put this B2, this will be sine theta 1, and C1, C2 will be your C2 sine theta 2. So this your will be, this whole vertical will be means lambda equals to B2 sine theta 1 plus C2 sine theta 2. Let us again try to understand this. This is what? This is a vertical part, this is a vertical part, this is horizontal portion, and this is the which is making because of inclined we are getting delta 1. So delta 1 having two components, one is vertical and horizontal. The vertical component is added over here, so this will be your delta 1 sine theta 1 plus delta 2 sine theta 2. We can always find out the delta 1 and delta 2 is given. Delta 1 and delta 2 is in this way, or we can find out this delta total, that is total vertical deflection for this and this added, and horizontal is your V, that is BB1 equal to CC1. BB1 is equal to CC1. BB1 equals to nothing, that is your delta 1 cos theta 1 equals to delta 2 cos theta 2. This is another relation in this way. So you can evaluate always that vertical, what is the vertical total deflection, that is delta, you can always find out. Now what is happening over here, if you take the moment over here, that is MAB equals to MBA, what will be there? That is minus 6 EI lambda 1 upon L square, L1 square, right? And M, your DC to MCD is also minus 6 EI if it is same into delta 2 upon L2 square. This is, you have to note it. And what about the total deflection which we are getting? This total deflection we are getting for this thing, this BC is to MCB equals to 6 EI, this will be positive EI, and lambda, this is total lambda divided by L square if it is L square. So this is, here we are using delta in this configuration. That is vertical deflection, but if B and C is considered, then whole deflection is created over here. This is the, so the relation between, you can say AB is to BC is to CD, maybe like this. This will be 6 EI delta 1 upon L1 square is to 6 EI delta upon L square is to 6 EI, that is delta 2 upon L square. These are the relation which we are getting from this graph. So with the help of this, you can say sin theta 1 is how much, sin theta is, if it is x, this is your Z1, this is you put Z1, Z, this is, we have assumed this is Z, this is Y, this is X. So this will be opposite. Sin theta 1 means X by the X horizontal part divided by Z. This is your sin theta 1. Remember, and cos theta 1 is just like उसमें लेते थे तो इसका उल्टा होगा Y, जहाँ कि होता था तो horizontal divided by hypotenuse, hypo, और ये vertical divided by ये. इसी तरह से the same relation is here in sin theta 2 and cos theta 2 equals to your y1 by z1 and x1 by z1. So these are the formulas, with the help of which we can always resolve this problem. So this is the theoretical part. Now we will take up the numerical to explore the moment distribution for this type of problem. Thank you for attending. Thank you very much.